good session tonight. Proportions and dimensional analysis. Nothing but word problems tonight. So I'm really looking forward to this. I really hope and I think you will find this helpful. We will have a mixture of some multiple choice and some fill in the blank tonight, because the TEAS7 does include those two question types among other question types. But tonight we'll have multiple choice and some fill in the blank. As we go through each individual question, I guess we could say with each question it's going to get a little bit more challenging, a little bit more difficult. To some of you it may seem like that, and that's kind of how I made it tonight. Definitely towards the end we'll be getting into some longer problems. Here's the first one for the night. I'm going to hush up for a bit and let's go ahead and get started. The correct answer for number 1 is going to be A. Now, some of you may have done a proportion, some of you may have done mental math. I'm going to show you the proportion way. And the thing I want to start to go ahead and drill home here is this. If you are comparing two things, a proportion is a good approach. Now, notice I'm saying the word things. Things, in this case, we have marbles, and we have two types of marbles. So the two things that I'm talking about in this problem, two things, we have red marbles and we have blue marbles. Now, later on tonight, we will have more than two things, and a proportion is not going to be the best approach. So since we have two things, proportions are fine. And I'm going to go ahead and show you multiple ways that you can set this up. A lot of people said, hey, I didn't set up my proportion like you did. That's fine. There's so many ways that we can set up this proportion and it will still work out every time. Now, one way I'm going to do this is I see for every 2 red marbles in the jar, there are 5 blue marbles. So one way, again, y'all, I'm going to show you different proportions that will lead to the same answer. So one way I can do this is I can put a 2 over 5. Now, could I have put 5 over 2? Yes, let's not worry about that. So what have I done here? When I write this fraction, the 2 is representing the red marbles, and then the 5 is representing the blue. And these words are not important. The words here are not important in proportions, but I'm just trying to point out what these numbers represent. So what I have done in this fraction is I have put red marbles over blue marbles. Did you have to do it like that? No. But watch what I'm going to do next. I'm going to put it equals. Proportions always have an equals in between them. And now over here on this side, for proportions, you want to keep things matched up. So what does it say right here? If there are 25 blue marbles in the jar, 25 blue marbles. Since I had blue at the bottom, I have red at the top. I want to keep this 25 at the bottom to match up. So if there are 25 blue marbles in the jar, how many red marbles are there? And we're going to put an X, you can put an R, you can put whatever you want. R for red, X, it's just a letter, it's a variable, it represents a number. So what we're going to do is we're going to cross multiply and divide. I'm going to show you the long way to do this. And again, I know somebody says, hey, I didn't set mine up like this. Y'all, I'm telling you, there's so many ways that we can set this up. I'm going to show that to you, and I'm going to go ahead and clear the air on that. There's so many ways you can set up these proportions. But once you have your proportion set up, you want to cross multiply. So cross multiplying 2 times 25, we get 50. Cross multiply the other way, so we're going to take this 5 times this x, and we get 5x. Now, does it matter which one we did first? Could we have done it in this order? Could we have done 5 times x and wrote that down, and then 2 times 25 is 50? Yes. It does not matter which cross multiplying thing you do first. Does not matter. Now, these two things that we have here, we set them equal, and then from here you want to solve an equation. You want to get that x by itself. So we need to divide by 5. And if you're unfamiliar with solving equations, that is a webinar that I've already done, but this is a basic equation here. We're solving for x, and if we do that, we get x equals 10. And that 10 does represent the red marbles, and that's what the question is asking. Now, let me show you another way, another proportion to do this same problem. If you did not set yours up like this, that's okay. Let me show you another way to do it. So maybe you did it like this. Let's go back to our question. For every 2 red marbles, there are 5 blue marbles. Some of y'all may have wrote a 2 on one side of the equals and a 5 on the other side. What we have done here is essentially I'm letting this entire side, when I create this fraction, I'm letting this side be my red side because the 2 was the red marbles, and I'm going to let the 5 over here on the right, this is going to be my blue side. This is a different way of setting up this proportion, but watch what happens. So if we read this question now, where are we going to put this 25? If there are 25 blue marbles, so since that 25 is blue, I want to put that on the blue side. And the question says, how many red marbles? I'm going to put that on my red side. Y'all, look at the cross multiplying. Look at the cross multiplying. Let me pull up 2 pages here and let me make this full screen. Hopefully you can see that, but these fractions are different. Y'all, what I have right here is not identical to this, but once you look at the cross multiplying, you will see that you're getting the exact same thing. 2 times 25, we get 50. I don't care where you write it at, first or second, it does not matter. And then if we take x times 5, that's still 5x. And what I want y'all to realize is that you're doing the same thing. There's so many ways to set this up. What is the difference between these 2 setups, y'all? This is what I want you to take away from this. This is where the true understanding comes from. In the first way, I put my reds at the top and my blues at the bottom. Could I have flipped that? Could I have put the blues at the top and the reds at the bottom? Absolutely. But notice I'm saying top and bottom. The reds at the top, the blues at the bottom. Well, look at what we have here. We have the reds on the left side, the blues on the right side. Yes, it is set up differently, but it's the same thing. It's the same thing once you start cross multiplying and dividing. Now, with all of that said, I want to show you a way that you can save some time on these problems. Once you set up your proportion, let's take this right here. So 2 over 5 equals x over 25. And once I'm done with this, y'all, I will be moving through some of these other ones a little bit faster, but this is, I'm trying to clear the air. There's definitely more than one way to set these proportions up. And now what I want to show you is a fast way to do this. On the calculator, here's how you can do the cross multiplying and dividing super fast, all at one time. So when you look at the cross multiplying, take the 2 numbers that don't have the variable with it. Now, what do I mean by that? So there's a cross multiplying, and here's our other cross multiplying. The purple one, the 2 times 25, we don't have the x with that. So what I tell students to do is take those 2 numbers, multiply those 2 numbers together. You don't even have to press equals. I'm trying to show you how to do this quickly in the calculator. You multiply the 2 numbers, and then whatever number is with the x, whatever that number may be, immediately go ahead and divide by it. This will work every time. So watch what I'm gonna do on the calculator. I'm gonna type it all in at once. 2 times 25. I'm not even gonna press equals. I'm gonna immediately divide by that 5, and notice we do get that same answer. I promise you this will always work with proportions. So with that said, let me give you one real quick, and then we're gonna move on to the next word problem. Go ahead and solve that one. What do you get if you solve for A? 10, 10, 10, 10, 10, 10, 10. I'm seeing it. Everybody's saying 10, 10, 10. That's exactly right. Ironically, it's the same daggone number that we got a minute ago. I just made this up on the fly, purely ironic. But what I want you to take away from this is that you multiply the 2 numbers that don't have the variable, so 7 times 90, and then you immediately divide by the number that is with the variable. This will always work. And this is what I'm going to be doing for the rest of the night, to go through these quickly because we need to work on our time. So here is number 2. Try it out. Got my notes here. The correct answer for number 2 is going to be C. Now, if you picked B, what you actually ended up finding was how much a single bag of chips cost. But watch what I'm going to do here. So what are we comparing? What are our 2 things? The 2 things are, we have bags of chips and cost, the money. Those are the 2 things we're comparing. Completely different than red marbles and blue marbles, but we still got 2 things. We got bags of chips and we have the cost. And notice in this first sentence, we are told that 60 bags of chips cost 90 bucks. I like to do mine this way. I like to put my first fraction with my 2 separate things. What does the 60 represent? The 60 is the bags. The 90 is the dollar amount, the cost. Now, again, some of y'all may have done 60 equals 90. That's fine. I'm just going to show one proportion. I encourage you to go back later and try, if it's not working out for you, try to make sure, or try a different way of setting it up. There's so many ways. I could sit here for an hour just talking about the first 2 or 3 problems. We wouldn't cover much if we did that. But I got bags at the top, dollars at the bottom. So let's see. How much does 3 bags of chips? Well, since I got bags at the top, I'm going to put the 3 up there. And it does say how much do they cost. So we're trying to figure out the cost, which is going to be that bottom number. Now that we have this set up, let's do it the fast way. What's the fast way? Multiply the 2 numbers that do not have the variable. 90 times 3. You don't even have to press equals. Immediately divide by 60. This is the fast way to do it. You're wasting your time if you go back and you start writing out this equation. And that's the time that you don't need to be spending on stuff like that. You need to do this the fast way to keep from running out of time. So 90 times 3 divided by 60. And if you did not set yours up like I did mine and you're still getting 450, then you did set it up correctly. And by the way, 4.5 is not $4.05. That is $4.50. All right. So 2 things. We got marbles, like red marbles, blue marbles. We have bags of chips and the cost of the chips. That's why I call it things, y'all, because the things can be literally anything. Speaking of, here is number 3. Try it out. Number 3, C is the correct answer. Identifying 2 things. That's my big idea tonight for the first half of this webinar, is when you see 2 things. We've got red marbles, blue marbles. We've done bags of chips and the cost. Now our 2 things are the ounces of weed killer, the concentrate, like Roundup or whatever. And we also have the gallons of water. These are the 2 things that are getting compared. Do y'all see how diverse the things can be? We've gone from talking about marbles to chips and money, and now we're talking about killing some weeds. So in our sentence, I like to find my 2 things right here. It is known that 6 ounces of that weed killer needs to be mixed with 1.25 gallons of water. Those are my 2 things. So 6 over 1.25, and the 6 is the ounces of weed killer. The 1.25 is the gallons of water. So let's set this equal to, if a loan maintenance crew plans on using 72 ounces of that concentrate, of that weed killer concentrate. Notice that right there. So ounces, 72. The question says, how many gallons of water? That's the missing piece. You may have set yours up differently, but if you cross multiply and divide, we should get the same answer. I'm not going to circle stuff anymore, but we are going to be taking that 1.25 times the 72, and then we can immediately divide that by the 6. And I want y'all to make sure you're understanding this fast way that I'm showing you here. So 1.25 times 72 divided by 6, we get 15. So, okay, a question says, why can't we do x over 72? I didn't say you couldn't. We can. This is what I was talking about earlier. This is just one way of setting up the proportion. Now, the student said, why can we not do x over 72? You can. As a matter of fact, I'm going to go ahead and do that. I'm going to put x over 72. But we have to acknowledge, okay, what does the x represent? What does the 72 represent? Well, the 72 is the ounces of concentrate. So we have ounces here. And the X is the gallons of water, because that's what the question's asking. The X represents essentially what we're looking for in this problem. So the X is the gallons. And all that we're really doing here is we're flip-flopping it. Instead of us having ounces at the top and gallons at the bottom, we're putting gallons at the top and ounces at the bottom. Don't make a hill of beans. Either way is fine. So let's see, 6 ounces. Where does that go now? The 6 ounces of that weed killer, we would put that down here. And then the 1.25 gallons, we would put that up here. Y'all see what I'm saying? Aren't we still cross multiplying the exact same numbers? We're still going to take the 72 times the 1.25, and you're still going to divide by 6. So this is what I'm talking about. I highly encourage you, when you're done tonight, go back and try to set it up a different way just to get comfortable. Don't stress out about saying, hey, I don't have this proportion set up like Brandon Kraft did. Hey, there's so many ways to do it. I cannot say that enough. There are so many ways to do this correctly. Now, some of y'all may have started to realize some quicker ways of doing it. So same problem, you'll still have all these different ways. Now, how would I do it? Now remember, I'm a math instructor, so how would I do this? The fast way. This level of understanding is not something that I can teach you like I can teach you proportions. Proportions is a way that you can just kind of set it up and let the cross multiplying take care of it. But what I would do, and this is what one student did, as long as you're comfortable doing this, here's how I would do it. I would take the 72 ounces and I would divide it by 6. Why? That comes on a different level of understanding. But yes, you can take 72, divide that by 6, and then you can multiply that by the 1.25 gallons. 72 divided by 6, we get 12, and then you multiply that by 1.25, you get 15. But I'll try to explain this to you. Why am I doing this? What I know is that 72 ounces of this concentrate, here's what that's telling me. We have to use essentially 12 times this amount. 6 ounces, well, we need 72 ounces. That's 12 times the amount of 6, because 6 times 12 is 72. Well, you have to use 12 times the amount of that gallons of water as well. That's what goes through my brain. That's the fast way of doing it. But y'all, I've said this numerous times too, not tonight, but I say it all the time. Do proportions if you get tongue twisted about knowing when to multiply by something versus when to divide by something. That's what proportions will fix for you. As long as you're matching something up. Are you matching them on the left and the right? Are you matching stuff at the top and the bottom? That's what proportions will fix if you set it up. It prevents you from making the mistake of knowing when to multiply versus when to divide. All right, let's see where we at. Number 4, fill in the blank. Check it out. All right, so with these fill in the blanks, you have to pay attention to what it says to do for rounding. For fill in the blanks, you could do all of this stuff correct, and yet if you don't round correctly, the fill in the blank will be wrong. There is no partial credit. You have to type it in exactly how they tell you to. Now, I will show the fast way here, because this is something that occurs not only on the TEAS, but in nursing school. The fast way to convert pounds to kilograms is to divide by 2.2. That is the fast way. You want to divide the pounds by 2.2. That's the fast way. Let me go ahead and show that to you. If we take 167 and we divide by 2.2, we get this crazy number right here. Those of you that typed in 75.9, had you typed that in on the TEAS test, it would have been counted wrong, even though you did the work right. You have to round to the nearest whole number. This means the nearest ones place, the ones place value. That 9 tells that 5 that is in the ones place to go up, 76 kilograms. So that's the fast way. As a matter of fact, that's exactly how I would do this problem if I was working it out by myself. Because I've done this, I've done pounds to kilograms. There's no telling how many times I've done that in my lifetime. I just know automatically. But let's look at the proportion. What are our two things? Our two things are pounds, LBS, and kilograms. So y'all, we have gone from red marbles to blue marbles, bags of chips to the cost of the bag of the chips. Heck, I already forgot what we did back here. Weed killer and gallons of water. Now we're talking about pounds and kilograms. The thing I want you to realize is that we are comparing two things in all of these problems so far tonight. So my personal preference, I see 2.2, that's the pounds, and I see 1 kilogram. So there's nothing wrong with us doing it the same, or me doing it the same way I've done it all night. I'm gonna put the 2.2 over 1. The 2.2 represents my pounds. The 1 represents the kilogram, according to that sentence. You did not have to put it in this order. Equals, where does the 167 go? The 167 is how much the patient weighs in pounds, so I'm gonna keep that at the top since I had pounds at the top of my first fraction. And the question says, how many kilograms does that patient weigh? That's gonna be the bottom piece that we're looking for. And if you look at this, all you're doing is this fast way. That's all you're doing, the fast way. Look, if you multiply these together, aren't you still going to get 167? So that is your pounds. What are you going to do to those pounds? You're going to divide by 2.2. It's just the fast way is the proportion, except we're not writing the proportion down. I hope y'all see how essentially the fast way is the proportion though. Now, had you multiplied by 2.2, if you take 167 times 2.2, I did see this answer popping up. Some of y'all put in 367 or 367.4. That is incorrect. That's not how you convert pounds to kilograms. Pounds to kilograms, you want to divide the pounds by 2.2. Do not multiply. So when would we multiply by 2.2? Convert 47 kg, convert 47 kilograms to pounds. To go from kg to pounds, you do multiply the kg by 2.2. That's when you would multiply by 2.2, when you're going the other way, when you're going from kilograms to pounds. So whatever that gives us, I'm just making up something. 103.4. All right. Those of you that got the 70, what was it? 75 point, I already forgot. 75.9. Some of y'all typed in 75.9. I knew that was coming. And I figured some of y'all were going to multiply instead of divide. So I got another fill in the blank right here for you. Please pay attention and do what it says to do when you type in your answer, the rounding in this case. Try it out. So we got to round this one to the nearest tenth. The correct answer is not 30. The answer will be 30 if you round it to the nearest whole number. The correct answer needs to be 29.6 using what's given to us up here. So to make fried rice, a recipe says to heat 6 teaspoons of cooking oil before adding the rice. Knowing that 4.93 milliliters are equal to 1 teaspoon, there's our two things. Let me go ahead and establish that. By me just typing this up here, I want y'all to start looking and recognizing that we're comparing two things in all of these problems so far. So two things, we have milliliters and we have teaspoons. There's my two things. There's my comparison. 4.93 milliliters is 1 teaspoon. Now, when you're in nursing school, more than likely as a nurse, you're going to be using 5 milliliters equal to 1 teaspoon. That is the most common conversion, but technically it's not 5 milliliters. That is an approximation. A more precise measurement is 4.93 milliliters. But anyway, there's our two things. I'm going to put my 4.93 over 1. 4.93 is the milliliters, 1 is the teaspoon. So what are we dealing with here? We know that we have 6 teaspoons of cooking oil, so I'm going to put the 6 down here at the bottom. And then the question says, how many milliliters are needed? Well, that's going to be our top part. So now we cross multiply and divide. Do we really need to divide here? I mean, sure, we're going to multiply these because they don't have the variable. The 4.93 times 6 does not have the variable. You're wasting your time. It's not going to hurt anything, but there's no need to divide because you would just be dividing by 1. Dividing by 1 does not change anything. So really all you're doing here is taking the 4.93 and you're just multiplying it by 6. And it does say to round to the nearest tenth. The tenths place is this digit right here. It's the first digit to the right of your decimal. That's the tenths place. And I did do a webinar on place value as well. That was earlier in this long series of webinars. But the tenths place is the 5. The 8 tells the 5 to go up, which is why we're going to have 29.6. Now, what you don't want to do, you don't want to type in 30. If you got 30, you're setting the problem up right. It's just that you got to make sure you follow those final directions for that final answer. So 29.6 is how you would want to type that in. Somebody said, what about 29.60? Well, y'all watch what I'm going to do here. I'm going to type in 29.60000. I'm going to put a bunch of zeros. That's still 29.6. Watch what happens. I'm not going to do any math. I'm not going to say plus, minus, times. I just type in 29.6 with a bunch of zeros. If I just press equals right now without doing any math, watch what happens. It just throws away those zeros. It's 29.6. All right, we are at the halfway point. Now we're not getting into dimensional analysis yet, but I'm gonna say right here is where things are gonna start to get, I think it's this problem. Let me look. Yes, things are going to start to get a little bit trickier, and I'm trying my best to get y'all to read the questions, and I'm really going to dive into that now for this second half. Try it out. The correct answer to number 6 is going to be B. You might say, what? What is this guy talking about? This is very similar to the first problem, except look at what this question is asking. The question is asking how many marbles are in the jar. It's not asking for just blue. A is just the number of blue marbles. But the question didn't say how many blue marbles are in the jar. So for every 7 red marbles in the jar, there are 4 blue marbles. There's our two things. So proportion, two things. We got two colors. So I'm going to put 7 red over 4 blue. So my top number, red, bottom number, blue. And it tells us in the problem, if there are 56 red marbles in the jar, since I put red at the top, the 7, I'm going to put 56 at the top, just because I put the 7 red at the top earlier. Now, what we're going to solve for here is we are going to solve for the number of blue. So let's go ahead and do that. But we cannot jump the gun. We still got to read our question. So the fast way to do this one, multiply your 56 and your 4, divide by 7, and I think that is going to give us 32. Let's double check that. Yeah, so there's our 32. But this is just 32 blue. But the question says, how many marbles are there? So we have to add on the 32 blue plus the 56 red, and we're going to get 88. And essentially, this is the total. That's what this question's asking for. Tricky, tricky, tricky. Read the question very carefully. So if you got 32, you essentially did the proportion correctly, but just make sure you answer that question that's being asked. Now, I'm going to go ahead and tell you, proportions is not going to be the best way to attack this one. And if you know how to do dimensional analysis, we're going into our dimensional analysis piece now. We got red, white, and blue marbles. We have three things. Try it out. All right, so dimensional analysis is something that I've really hit hard on. And technically speaking, every single problem that we have done tonight could have been done using dimensional analysis. However, approaches to solving a math problem, proportions should still be in that toolbox. You definitely want to know how to do proportions. However, you might say, well, how in the heck am I going to know this is dimensional analysis? Here comes the big question. So I'm going to put it in caps. How many things do we have in this problem? We got three. We got three things. We don't have just red and blue. We have three colors. We have three types. So we got red, white, and blue. So I'm going to go ahead and tell you, a proportion will not solve this. You would need to do more than one proportion. And that's okay if you want to do that. But what I prefer, if you have more than two things, dimensional analysis is a great approach. So I've talked about things all night. Hopefully you've heard me say that enough, and I'm going to say it some more. But I've talked about things. How many things? And this is the first problem tonight where we have had more than two things. So in this case, if there's more than two things, I like to use dimensional analysis. How do we do it? Well, just like with proportions, there's more than one way to do proportions. But I do have a specific way that I tell students, hey, you can set up dimensional analysis incorrectly. But there's one way I can guarantee you that you can always set it up correctly. So this is very specific. There is a way that guarantees, let's see if I can spell this right, Guarantees, yeah, that's right. There is a way that guarantees that you are setting up your DA, dimensional analysis, correctly. How? Here's the question. What are we trying to find? This is what you want to ask yourself. When you're doing dimensional analysis, ask yourself, what am I trying to find? What is the question asking us to find? The question is asking us to find how many red marbles. That is our goal. And by the way, this technique is the only technique that you need to know for med dosage pretty much. Once you get into nursing school, this technique I'm going to show you here is the only technique you need to know for 99% of the problems. So what are we trying to find? We are trying to find the red marbles. So why am I hitting on this? Why am I telling you to focus on what you're trying to find? I'm going to write a fraction down, and I'm going to put the word red at the top. This is how we're going to start off dimensional analysis. This is how I can guarantee that you are setting it up correctly. Ask yourself, what are we trying to find? The question's asking for red, so start off with that word. Now, words are important. Start off with that word at the top of your first fraction. Now let's go back and read. What's something that we know about red? It just so happens it's mentioned near the very beginning of the problem. 3 red, there are 3 red for every 10 white. So I'm going to put the 3 for every 3 red. You have to do it in this order if you're going to follow this technique. 3 red for every 10 white. Now, I'm going to multiply. I'm not putting an equals in here. I'm not going to put a variable in here, y'all. This is different. This is not proportions. This is a different technique. So notice I'm not putting equals. And automatically what I'm going to do is I don't want this word white. The question does not say how many white marbles are there. I don't want white. So we want to get rid of that word. The words are important. How do we get rid of this word? Since white is at the bottom, I'm going to automatically put it at the top of my next fraction. This is going to let you cancel out the words. And that's what dimensional analysis is all about. Getting rid of the words. Well, we can't just write the word white and cancel it out. We got to look at our problem. What's something else that we know about white? Do not repeat the 10 white again. We've already said that. Do not repeat it. What's something else we know about white? For every 5 white marbles, there are 7 blue marbles. 5 white. I'm going to put that 5 at the top. For every 5 white, there are 7 blue. Well, we have crossed out the white, but now we have the blue. We don't want blue in our answer. The only word that we want in our answer, the only word is what that question is asking for. The question's asking for red. That's the only word I want in my answer. So we got to get rid of blue. How do we get rid of the word blue? Same way we got rid of white. Since blue is at the bottom, I'm going to put blue at the top. And let's look and see what's something else that we know about blue. We have 70 blue marbles. Now, what do we put this over? And this is more for, I guess, decoration or a placeholder, but I'm going to put it over 1. And what that 1 represents, it does have a meaning, y'all. This 1, notice what it says. There are 70 blue marbles in that jar. So essentially that 1 means that 1 jar, but you don't have to worry about getting rid of that word. You don't even have to put that word in there. I'm just trying to show you that, yes, it does have a meaning. We're just not throwing a 1 in there for the heck of it. That 1 means that 1 jar. That 1 jar does have 70 blue marbles in it. Now, if you think that's cool, we're not done, or maybe you don't think it's cool, but we're going to do some more examples. Grab your calculator, and I want y'all to pay special attention to how I show you how to do this as fast as possible. What I want you to do, we're not cross multiplying. Nuh-uh, do not cross multiply. These are not equals. Do not cross multiply. Multiply all of your top numbers. So 3 times 5 times 70. And y'all, I'm not even going to press equals. You can if you want. So I've typed in 3 times 5 times 70. And you can press equals, or you can immediately start to divide. We're going to, every time, we're going to multiply all of our top numbers, and we're going to divide by our bottom numbers. So watch how I'm going to type this in. I've already done 3 times 5 times 70. I'm going to press divide. I'm going to type in a 10 because that's one of my bottom numbers. And then I'm going to press divide again, and I'm going to type in a 7 because that's a bottom number. And you can press divide again if you want, but you're wasting your time. There's no need to enter the 1s in. So if I press equals, now let me copy this over. I want to make sure you can see exactly how I type this in. Look at this. Look at what I've done here. 3 times 5 times 70. I've multiplied all of my top numbers. And I didn't press equals. You can if you want, but I didn't. Immediately start dividing by the bottom numbers. Divide by 10, divide by 7. And notice how many times did I press equals? Just once. That's right, just 1 time. This is the fastest way to do this. Once you write out all this crazy stuff, that's the fastest way in my opinion. So our final answer is 15. 15 what? It's the only word we didn't cross out. It's that word we started off with. It is that word that the question was asking us to find. 15 red. Now I know you're itching for another one, so that's what I got. 3 things, there's your hint. Try it out. It's okay if you didn't get this right. If this was your first time seeing dimensional analysis, I don't expect you to get it right. The answer is A, and I have a bunch of videos on this topic of dimensional analysis, and I can link some of those right here in the notes, and you can go practice those. Pretty much you're going to hear me say the same thing again. You know, how many things do we have? I want you to notice we do have 3 things yet again, don't we? It's just not marbles, now it's Legos. Who cares what the object is? Who cares what the thing is? We've had so many things tonight. We have yellow, we have red, and we have green. I don't care if it's marbles, it could be chips and candy, it could be plants. It's things, y'all. I've said things numerous times tonight. So dimensional analysis. So what are we trying to find? Trying to find red. So guess what I'm going to do? That same approach. If you have more than 2 things, we have 3 things. I can guarantee you, you are off to the right start if you start off with what you're trying to find. So my first fraction, red. Now, I can't guarantee that the word red is going to be the first color that pops up. Actually, yellow is the first color that pops up. Don't start off with the 16 yellow. Don't start off with the first number. Start off with that red. So what do we know about red? For every 7 red, there are 16 yellow. Had you put the 16 yellow at the top, it would be wrong. You are not off to the right start. If you start off with what you're trying to find, I can guarantee you it will work itself out with practice, of course. So what do we need to get rid of? We don't want yellow. Same thing now. I'm going to put yellow at the top. Let's look for some yellow stuff. Don't use the 16 again, but we got 8 yellows. And what do we know about these 8 yellows? For every 3 green Legos, there are 8 yellows. So I have 8 yellows. I'm going to put that 3 green at the bottom. And we need to get rid of green now. Let me go ahead and cross my words out. So what else do we know about green? There are a total in that one bin. So there's that 1 again, more of a placeholder. There's 132 green in that one box of Legos, that one storage bin of Legos. Cancel out your green, and now we do the same thing. Multiply all of your top numbers, divide by all of your bottom numbers. So grab that calculator. Let's make sure we are doing this as fast as possible. Huge time-saving tips, in my opinion. So 7 times 8 times 132, divide by 16, divide by 3. Let me copy this over so you can see how I type that in. Any questions about number 8? For this one here, I said the rest of the night is going to be dimensional analysis. See if you can crack this code right here. Try it out. Number 9, the correct answer is going to be B. So what are our 3 things here? So we do have 3 things. 3 things. I see some people, 216 people, so that has a number to it. I see cups of sugar. And then look at what the question's asking us. Bags. Those are our 3 separate things. I know it's not colors anymore, like red, white, and blue, but it's still 3 things. So the question says, how many bags of sugar? So what do we know about bags? And it's kind of tricky. This one doesn't pop out like all the other ones have done so far. Sugar is sold in bags that contain 16 cups. So what that sentence is really saying is it's saying that one bag has 16 cups in it. I know it doesn't say one bag, but you have to infer that. Sugar is sold in bags that contain 16 cups. So every one bag has 16 cups in it. Now from here, it works out just like the color stuff we just did. So what do we want to get rid of? Cups. And what do we know about cups? 6 cups of sugar will serve 9 people. I hope y'all are seeing the similarity now. Even if you don't fully understand it, I hope y'all see it. It's the same thing. We're getting rid of words. And now we want to get rid of people. And we know there's a total, grand total of 216 people. And that can be that one party that Samantha's making all of this ice cream for. But yeah, we've gotten rid of everything. Same thing, y'all. Grab your calculator, see if you can get this answer. I always skip the ones. You don't have to type in that one or that one. You can if you want. It's not going to hurt anything. So my 2 top numbers I'm really just multiplying are 6 times 216. And then I'm going to divide by the 16, and I'm going to divide by that 9. And the final answer is going to be 9 bags. You know, very rarely in math when I'm teaching stuff, like earlier tonight, I was saying, hey, there's so many ways you can do proportions. When it comes to dimensional analysis, this is the only way that I teach it. I can guarantee you that it's always going to work out, of course, with practice, if you start off with what you're trying to find. There are other ways of doing it, but this is my guarantee. I do see a comment where a student was saying, hey, I took this times this, I divided by this, and then I multiplied by this. Hey, if it ain't broke, don't fix it. But if you get confused about knowing what numbers you should be multiplying by versus what numbers you should be dividing by, that's what this takes care of. All right, so we got one more, y'all. Here's our last one for the night. This is a fill in the blank. Try it out. All right, so the last one for the night, I'm going to start off by showing you the fast way because, again, is knowing when to multiply versus when to divide. Here's how I would do this if I was by myself. The family traveled, and I'll show you dimensional analysis too, right here in a moment. But the family traveled 2,000 miles, and their vehicle will get 25 miles per gallon. What we can do with those two numbers, if we take the 2,000 and we divide it by 25, 2,000 divided by 25, so we get 80. What this 80 truly tells us here is how many gallons of gas they used up. They went 2,000 miles and they can go 25 miles on 1 gallon. That's what 25 miles per gallon means. You can go 25 miles on 1 gallon of gas. That 80 represents 80 gallons. That's how many gallons of gas they used. And since the gas cost $4.25, all we really have to do here, if you can follow along with that first step, is we just multiply 80 times $4.25 per gallon. $4.25 per gallon times 80 gallons. There's our answer. There's no need to round. We get 340 bucks. But let me duplicate this, and actually dimensional analysis might be slightly overkill here, but it still does work. So watch what I'm gonna do here. Dimensional analysis. What is the question asking us to find? How much money? Whereas earlier tonight, it was saying how many red marbles or how many, what was it, red Legos, or what was this one right here? How many bags? This one's asking how much money. Well, the only thing we know about money in this problem is we know that it cost $4.25. I'm still starting off with what the question's asking me to find. I'm starting off with money. $4.25 is how much 1 gallon of gas costs. I got dollars over gallons. Let's get rid of gallons. Well, what's something else we know about gallons? 1 gallon of gas will take the family, or their vehicle will go 25 miles on 1 gallon of gas. That's what that means. 25 miles per gallon means they can go 25 miles on 1 gallon of gas. Now, why did I put it in this order? Gallons cancel out. Now, what other word do we need to get rid of? The mileage. That way we can cancel out the miles at the bottom. So we have 2,000 miles. I can put this over 1. That represents the one trip, the one road trip the Griswolds took. Maybe I like that little comparison right there. Griswolds, one of my favorite movies. About time to watch it. Christmas Vacation, if you haven't seen it, is hilarious. A lot of ones here, but we still want to multiply and divide just like we've done for the last, 3-4 problems. So $4.25 times 2,000. And then the only thing we have to divide by is the 25. And you can see we do get the same answer. So 340 bucks. We hope you found this webinar helpful. For even more webinars, countless hours of videos that covers all of the goals and objectives for the TEAS7, check out TEAS.archerreview.com. At this website, you can pick up the question bank or the webinar videos or the combo bundle. And once you have access to those resources, whether it be the question bank where you can create your own test, you can select specific goals and objectives to work on, and then for the on-demand lectures, hours upon hours of video lectures that cover all the goals and objectives set by ATI for the TEAS7. And these videos even include notes that you can download and follow along in those webinar videos. So again, check out TEAS.archerreview.com for those additional resources.